Alright, so in this video we're going to go through how to find the future value of an annuity. So in this case what we have is an annuity of $500 per year. So we're trying to find the future value in 4 years of $500 per year at the end of each year. The interest rate is 10% per year compounded annually. So as you might guess by now, we're going to do a timeline, and we have 4 years. And the rate per year is 10%. And we have $500 per year at the end of each year. So let's put those on the timeline. Now if we're trying to find future value is equal to present value times 1 plus the applicable rate of interest raised to the number of periods. So in that case, what we're going to do is we could find the future value of each individual cash flow. So let's go ahead and try that. So if I want the future value after 4 years, then in this case, this $500 at the end of year 4 is already the future value that we need. So I don't need to do anything to that. But we will first need to find the future value of this $500. So to find that future value, we're going to have $500 times 1 plus the interest rate, which is 0.1, raised to the number of years, and we only have 1 year that we need to move it into the future, so it's going to be raised to the 1. And if you work that number out, and I'll give you a moment to do so. Alright, returning to the video, assuming you paused it to work it out, that number should work out to $550. So then what we're going to do is we're going to do likewise for this second cash flow. So the future value is going to be equal to $500 because that's the value here in year 2 that we're trying to find the future value of in year 4. So we'll take 1 plus 0.10 raised to the, in this case, 2 because we have 2 years. So now I recommend that you pause the video to find out what that works out to. Okay, so if you pause the video and worked it out, you should have gotten $605. So our next step is to find the future value of this cash flow. So future value is equal to 500 times 1 plus 0.10 raised to the 3rd power because we have 3 periods that we're trying to move this forward into the future. So in this case, I recommend that you pause the video and work out the number. Okay, so if you paused the video and worked out the number, you should have gotten $665.50. Okay? So now that we have all of these cash flows as of the end of year 4, to find the overall future value, all we have to do is add them all up. So I'll give you a moment to do that. Okay, so if you added them all up, then what you should have gotten is $2,320.50. So that would be the overall future value in 4 years of $500 per year at the end of each year if the interest rate was 10% compounded annually. Well, as it turns out, we could also do this with our calculator as well. So let's go ahead and do that. So if you're using your calculator, you again have N, I, PV, FV, payment, and type. So N is the number of periods, I is the rate per period, payment is the amount per period. So in this case, we are dealing with $500 per year for 4 years. So N is going to be 4. I is the interest rate, and it needs to be the rate per year, so that's going to be 10. And in this case, the payment is $500, and we do have an annuity because it's the same amount every period for a specified number of periods. So our payment is going to be $500. Our future value will be what we're trying to find in a moment. Present value would be if I had another cash flow here at time 0, which I don't. So we're just going to put in 0 for that. And in this case, because we do have an annuity, the type of annuity does matter. So for this problem, because it is a cash flow of $500 per year at the end of each year, it is an ordinary annuity, and therefore the type here is end. So in that case, you should be able to solve for the future value by going down to the future value line, hitting the alpha key, and then hitting enter. I'll give you a moment to do that. Okay, well, if you did that, then lo and behold, you should have gotten a value, which I'm not sure you can actually see here, but you should have a negative $2,320.50, which of course matches with what we have here, with the exception of this negative sign. And again, your calculator is adding on that negative sign, so you have to take that with a grain of salt. Now, if you wanted to find the future value using Excel, then the way that you could do that is equals future value times the rate, which in this case is 10%, and then the number of periods, which is going to be 4, and then the payment amount, which in this case is $500. Our present value is 0, or we don't actually have it, so you can actually leave that amount off. And we also don't need to have the type either. So you can just end your formula there. And if you solve that out, you should get the same answer, which is negative $2,320.50. And again, in this case, if you actually wanted a positive value in that cell in Excel, then what you would need to do is put a negative sign here in front of the future value, and that would turn that value positive. Now, if you actually looked in the textbook, which I recognize might actually be somewhat of a radical concept for some of you, you may have actually encountered a formula indicating that you can find the future value of an annuity by using this formula. So let's go ahead and give that a try. So in the numerator, what we have here, well, let's start off with our payment. So in the numerator here, then we have 1 plus I, which is our interest rate, so that's 0.10, raised to the n, which in this case is 4, minus 1, and this is all over the interest rate, which is 0.10. So I'll give you a moment to try to work that out, and then I'll come back and see how we did. Okay, so if you took a chance on working that out, let's kind of go step by step and see how this works out here. So if we have 1 plus 0.1 raised to the 4th, what you should get is a value of 1.4641 minus 1 in the numerator over 0.10. And then if we work that out, so this is going to be 1.4641 minus 1, which is going to give us the 0.4641 divided by 0.1, which gives us 4.641, which then we are going to multiply by 500. And if we work that out, we get the $2,320.50, which is the number that we had gotten the other ways as well. I recommend you try some similar problems and see how you do.